And since this one can be solved easily by the use of certain equations, Ricardo equation, certain equations, so we must use the quadratic form if the control target is not given in the quadratic terms. We cannot solve it using existing method 40 years ago. However, this is not actually the kind of criteria we need in process control. In process control, when we introduce a input signal, such as a step input signal, we want the output of the signal follows the input signal as quickly as possible, and the error should be as small as possible. This kind of thing is not quite good expressed. It's not quite well expressed in the criterion here. So the mathematicians might introduce a criterion like this. Why? Because it can be solved easily at that time. But this one has nothing to do with the requirement I gave there. And there are also bad things. For instance, you have to select Q and R matrices, and there isn't any uniform accepted way to choose these matrices. So this objective function is artificial. It is not as direct as the other one I will give later. And then they introduce a criterion like this. And for the signal following error, they introduced the finite time state variables and impose a weighting here. So if the weighting is selected correctly, then the output of the system may become, the x may approach to 0 as quickly as possible. So they use a finite time LQ control design. However, they found that this kind of control design results in a dynamic algebraic equation, which is quite difficult to solve. So they changed the criterion again. Why? Because they cannot solve it. So they changed this one from the control problem into a regulator problem by specifying that the finite time here is infinity. And this will lead to an algebraic Ricardo equation, which is easier to solve. So the mathematicians want to introduce this kind of criterion and find the optimal controller. But the requirement here is far away from the actual requirement by the engineers. It's just mathematical games. I think the application of LQ kind of controller are smaller and smaller now. And also there are other criteria such as the H2 error minimization or H-infinity minimization problems. However, the H-infinity ones are too conservative. And I shall explain H2 later to you. And apart from this criterion, there are also other criteria for optimal control. For instance, there is a so-called fastest time response, which usually results in the Bang-Bang control. And also, sometimes one may be interested in the smallest cost criterion, which can be expressed in certain ways. And apart from these control criteria, there are several useful criteria such as the error-based criteria, which are more close to the engineering requirements. For instance, the criterion which I call it, which is called the ISE criterion, which use the error, the square of the error, the integration of the square of error as the criterion and make it the smallest possible. And this one is equivalent to the H2 minimization criteria. And in literature, you may find that there are quite a lot of papers on H2 optimal control or ISE optimal control. Apart from this kind of control, we can usually introduce other criteria, such as ITAE criteria, where we impose a weighting T in the area. Also, we may have IAE criteria and also finite time ITAE criteria. And by comparison, you may see that for a certain example, for a certain plant model like this, if I want to get a PID controller, then if I use H2 criteria, we can find the PID controller parameters using commands like this. I have defined I have defined the objective function first. Well, I shall not demonstrate this part because I have already used some time to demonstrate it in another course. So I only gave the main conclusion from the comparison. If I use ISE criterion, then the optimal controller for a certain example may be something like this. Why there is oscillations? Because in ISE criterion given here, they treated the error at any instance equally. However, in control, we expect the response to get close to zero, get close to the steady state value as soon as possible. So we can introduce weightings like this. And this one is called ITAE criterion. And for this kind of criterion, the optimal control result may be something like this. It is slightly slower than the ISE criterion, but the settling time of this one is much faster than the other optimal controllers. So it should be concluded that ITAE criteria has certain advantages over ISE criteria. However, ITAE criterion is evaluated on top of the simulation result. However, ISE criterion can be obtained by solving the Riccardi equations and find the results. So there are differences, advantages and disadvantages. As I said, in literature you may find that there are quite a lot of papers on ISE criterion or H2 norm minimization problems. However, as I concluded here, ITAE criterion have even much better performance than the ITAE criteria because it weights the time, it weights the error with the time, and when time is large, then it forces the error to get to approach zero as soon as possible. So that one is maybe gives better performances. So based on this control method, I developed a Matlab function called OCD, an interface. And with the use of OCD function,